Hello, you're on Pablo Spot. I'm George. Welcome to this new series where I focus on setting up load balancer infrastructure. And I will start this series with a basic show and tell on setting up a simple redirect using Application Load Balancer. And so if this series and the content of this channel lines up with your interests, hit the subscribe button and join me in this journey of learning by doing. So, let's start coding. Let's get straight to it. I have this empty local repository that I've created for this series. And so on my VS Code terminal, I will start by running my script to create the base Terraform code for today's episode. And now if I head back to my VS Code Explorer, I now have templates that I can use for my code. If you are following through the steps that I will show you today, remember that I will be creating load balancer resource. This resource involves cost that is, I think, worth noting. I will be destroying this infrastructure at the end of this episode to minimize the cost that I will incur, and you might want to do the same. What I need to do now is set up my backend.tf for the appropriate workspace parameters for my Terraform state files. So let me open that file. And as you can see, my backend is set up to use Terraform Cloud by default, so I'm not going to change that. However, I need to set my organization and my workspace is blocked. Load balancers are used to proxy web requests and public access to web services or applications that are running in a protected space in an infrastructure. Now let's go ahead and create the load balancer resource. So let me head to my main.tf. I'm going to start writing the code to create a load balancer resource. I'm going to set the name property on this resource, which is a required property. I also want this to be an application load balancer, so I'm going to set the load balancer type property to application. I want this load balancer to be accessible to the internet. Firstly, I need to set the property called internal and set it to false. Generally, when load balancers are used to marshal requests from the internet, this load balancer resource is configured to run on a public subnet. On this episode, I will be using the default VPC on my AWS account to set up my load balancer, which means on my main.tf, I will define a resource reference to this default VPC. Remember that this is one of a few special resource blocks that does not create an actual resource in your infrastructure. What this will do is create a reference to an existing default VPC on my AWS account. When you sign up for an AWS account and you access the VPC service, you will notice a preset VPC resource that exists on each region on your account. And this is the default VPC that the resource block of my code is referencing. Now that I have this VPC defined, I then need to get the public subnets that are associated to this VPC. And so on my data.tf, I will need to define a data reference for AWS subnet IDs. And add a filter block that will contain VPC ID as the field and a value that points to the ID of my default VPC resource. And then on my main.tf, I can then add a new property on my load balancer resource called subnets. And point this to the IDs property of my AWS subnets data reference. Setting up the subnets property of my load balancer to multiple subnets ensures redundancy on the load balancer. Each subnet acts like an independent data center, and in the event of disruption in any of the subnets, my load balancer will remain accessible through the other healthy subnets. Before I set other properties on my load balancer resource, I'm going to stand up my infrastructure. And because I need to verify this once it is created, I will first head to my outputs.tf and add an output variable that contains an HTTPS URL, which also has reference to the public DNS of my load balancer. And now, let me switch to my VS Code terminal. The first thing that I need to do is create my workspace in Terraform Cloud. I have a script that will take care of doing this, but I need to first export some environment variables for it to work, starting with TF workspace. I also need to export TF workspace prefix and set this to the same value that I use inside my backend.tf. And now I'm going to run my script that will create my workspace in Terraform Cloud. To be able to stand up my infrastructure in AWS, I also need to set my AWS credentials, and I will use AWS Vault for this. And now I'm going to run my Terraform commands, starting with Terraform init. Now that Terraform has been initialized, I'm going to run Terraform plan. Terraform plan is complete. Let me apply this infrastructure. My infrastructure is applied successfully. So what I will do next is copy the output string on my run. And then run a simple curl command to attempt to access my load balancer. This command is taking a while to complete, and I know that this will eventually time out, so let me cancel this. One of the reasons why this is not working is because my load balancer is not configured yet to listen to port 443, which is the HTTPS port. So what I will do is head back to my code, and introduce a new resource block for my load balancer listener. So at the end of the main.tf, I need to link this listener resource to my load balancer. So I'm going to add a new property called load balancer ARN and point this to the ARN of my load balancer resource. I'm going to set the port, protocol, and SSL policy properties that coincide with HTTPS handling. So I'm going to start setting up the port property to 443, the protocol property to HTTPS, and the SSL policy to the latest AWS SSL policy available. I also need to attach a certificate to this load balancer, which will be used to terminate the SSL. I already have an existing certificate that I can use. So what I will do is head to my data.tf and create a data reference to my existing ACM certificate. And then I will head back to my main.tf and update the certificate ARN property of my load balancer listener to use the data reference that I've just set up. The next property that I need to set for this load balancer listener is the default action block. This will determine how my load balancer will behave by default when it receives a web request. I'm going to set the type of this block to redirect. And then add the redirect block. I will add the status code property inside this block and set it to HTTP 301. This means my load balancer will enrich the request trail and indicate a response code 301 when it processes the request. This response code indicates a redirection of the request. I will make my use case simple and set up a default action that involves redirection of web requests to google.com when my load balancer receives the request. And so inside the redirect block, I will add a new property called host and set this to google.com. And then set the port to 443. And the protocol to HTTPS. And now let me head back to my VS Code terminal and then update my infrastructure. So firstly, I'm going to run Terraform plan. And then run Terraform apply. And now I'm going to rerun my curl command again to attempt to access my load balancer. So that is also taking its time. So let me cancel that. My curl command is still not working. This indicates that my web request is not hitting my load balancer. And the reason for this is by default, attempts to access the load balancer on any ports are blocked. What we need here is a firewall resource called security group. So let me switch back to my code. And on my load balancer resource, I need to add a new property called security groups. This property expects a list of security group IDs. And each security group ID corresponds to a security group resource that defines firewall rules for accessing the load balancer. So let me head to the end of my main.tf And I will introduce a new resource called security group. I'm going to set the basic properties for this resource that include the name and the description. And because this is a public-facing load balancer, I will add an egress block that will allow access to the internet. Inside this block, I will set the from port and to port properties to 0. What this means is that I'm allowing my load balancer to be able to access any ports in the internet. I will also set the protocol property to -1, which means all protocols are allowed. And lastly, I will set the CIDR blocks property to a value that encompasses any IP address in the internet. I also need to define rules for incoming requests, so what I will add is an ingress block. I have set up my load balancer listener to listen on port 443. And so I will set the from port and to port properties to port 443. This indicates that I'm only allowing access to port 443 on my load balancer. I'm also going to set the protocol property to TCP. And then set the CIDR blocks property to a value that allows public access. And then lastly, I need to associate this security group with a VPC. So I'm going to introduce the VPC ID property and point this to my default VPC resource. And now that I have this security group defined, let me head back to my load balancer resource and update the security group's property to contain a reference to the security group ID that I've just created. And now, let me head back to my VS Code terminal and run Terraform plan. And run Terraform apply to update my infrastructure. And now that my infrastructure is updated, I'm going to rerun my curl command to attempt to access my load balancer. This error message is a good indication that my load balancer is accessible. And to prove this, let me switch to my browser and plug in the URL to my load balancer. I'm getting this strange prompt on my browser which coincides with the error message we saw from the console earlier. But what I'm going to do is bypass this error message. And if I go ahead and load this up, I should eventually get redirected to google.com. This shows that the redirection works. And that's all I have for today. Stay tuned for more episodes on this series where I cover cost management and best practices when setting up load balancer in your infrastructure. In the meantime, let me know your thoughts in the comments below and send me some likes if you find this useful. And don't forget to hit the subscribe button if you like the content on this channel. Until next time, keep learning and stay safe. See ya.